welcome back, Mindsetters. I hope you did have a little jog around the room just to get your brains revitalized. And also, if you may have some questions, please shoot them through to us just so that ET can go through them. But for now, keep your focus on, guys, because this is such important stuff to go through. And this is where you guys can start taking your notes and stuff and start maybe revising, because exams are soon. It seems like they're far, but they are soon. And some of you are going back to school this week as well. So make sure that everything that you have is just up to date, guys. And so is your work. Your work must always be up to date. Over to you, E.T.
Katlego, I now want to wrap up on this periodic functions.
Okay.
But I want to rather give it to them as a challenge question.
Okay,
They
that
can do
would
it
be
at home.
perfect. Okay.
I've got a periodic function that's both translated and scaled up and all that. So it says y equals to tan of 2x minus 90, all in bracket, plus 3. Please go and try and draw this graph and see what the shape will be like. All right, so it's testing everything, almost everything. All right, so I want to move on to non-periodic functions. I'm saying draw graphs of the following algebraic functions, starting with a simple one like y equals to 2x squared. All right, you will identify this as a quadratic function. And the graph that you have coming out of this quadratic function is called a parabola. So the graph out of a quadratic function is called a parabola. And that's what I'm asking you to draw. Okay? Notice that this graph, if it was a parent graph, it would have been y equal to x squared. You have a coefficient on the x squared term, and that is a coefficient 2. It's simply scaling this up by 2 units. A scale factor of 2. So what you will then have, if you look at a parent graph of a parabola, it would have been something like that. You can see the features of a parabola there, symmetry, and a turning point, and the y-intercept, all that. So what you have done now is, if this was 1, you would have, if it was a parent graph, it would be 1 squared, which is just 1. Okay, so 1 would correspond to 1. If you substitute there, that would have been a point there. Now, if it was 2, that would come out to be 4, or 2 squared. Now, what you're doing with these values of y, is to basically multiply them by 2. So if you multiply this y value of 1 by 2, you're going to end up with a value of 2 somewhere there. Okay, so let's start off with a 0, with a 2 there. And if you multiply that value of 4 by 2, you're going to end up with a value that is 8 somewhere there. And that becomes your graph. That's how you can quickly sketch your graph. All right, so I'm sure some of you, are saying, well, we know how to do that, but let's just move on to a bit of transformation. Here, what we do is, yes, we've scaled it up, and we also translate it. Now, it's a few combinations now. We're going to translate it vertically by adding a 3 or taking away a 3. So let's take it from the parent graph. If this was your parent graph, in this case, let's take it from 2x squared. So if this was a graph of y equals to 2x squared. So all you would have to do in this first case, we call this y1 and this y2. In the first case, you would have to increase every critical value, every defining feature, you'd have to lift it up by 3 units. So let's say you end up somewhere there with your turning point. Okay, so if there was another point here, which was say 1 and 2, you're going to end up with that point sitting up there, multiplied by, first of all, it was multiplied by 2, then 3 was added to that. Okay, so that would end up being 5 units. 5 up there. All right, so that's just the first one, that's y1. This represents y1. Then you've got y2, which says subtract from each y value on the parent graph, on the graph of 2x squared, take away 3 units. And then you're going to end up, let me just use a different pen there. You end up with, if it was 0, now it will be moved, how many units? 3 units down. So you end up at -3. Did I say 2 there? Let's see, yeah. Then you end up with a graph that looks like that. Simply just shifted down 3 units. I did not point out the new value over there, which is going to be 3. Okay, because it was 0 initially, now it is 3 units up. Okay, that's how you would actually translate your quadratic function. Notice that in this case, our line of symmetry, because we don't have the middle terms in this expression, our line of symmetry is still your y-axis. So this is because you've got an expression that says ax squared simply plus b. You don't have the x term. So remember, a quadratic function has got 3 terms. It's a trinomial. So it would have been y equals to ax squared plus bx plus c, but you just don't have this middle term. So let me just represent this one so that you at least relate to these symbols. So in this case, what you then have is just ax squared plus c. The b term is not there. And now, obviously, you're beginning to realize that the x term has a tendency to change the axis of symmetry of your parabola. Okay, so that's what you have seen with these two translations and scaling. We can move to the next one. Let's see. Now, what I have done is I've brought in the b term, the x squared, the x term, which was missing in the other equation. And let's see what that does to this problem. All right, if we take it one more. Right. So if we had our graph, the parent graph, sitting at that point, like that, the graph of y equals to 2x squared. And now we introduce the x term. What is it going to do to this? Now, if you factorize this, let's take the first one and call it f of x equals to that. This one we'll call g of x equals to 2x squared minus 3x. So what will happen here is, remember the features now, very important for any function when you draw the graph. You need to know what are the defining features. For a parabola, yes, we have a turning point. We have the y-intercept, one y-intercept. And we've got a maximum of 2 x-intercepts. You can have 0, you can have 1. So if you have an expression like that, how do you find the y-intercept? For y-intercept, we let our x equal to 0. So in this case, we end up with y equal to 0 anyway. All right, so this graph will have, will still pass at that point, at the origin. What about the x-intercept? If I may just buy space here. For x-intercept, what we do is let our y equal to 0. That tells us that 2x squared plus x will be equal to 0. Now, is the case of factorizing there. Then we say take away, take a common factor of x. Then you've got 2x plus 1 there equal to 0. Your x-intercepts will be x equal to 0 and x equals to minus half. All right, so if we have those three important informations, the y-intercept, the x-intercept, and we know the turning point, do we? No, we don't know the turning point. That's another thing we're going to have to determine there. And all right, how do we determine the turning point? So we've got that. How do you determine the turning point? One little formula that you are going to have to use. At the turning point, x, let me call it P, x at the turning point will always be minus b over 2 times a. So b and a represent the coefficients of x squared and the coefficient of x. All right. So if you look at b, our b was 1. So we substitute it. All right. Then we divide that by 2. Where we see a, we put 2. So which means our x-intercept, our axis of symmetry is going to be at minus 1 over 4. All right. So now we've got all the important features that we need to show on the graph. And quickly, let's see. I think we're just short of the y at the turning point. So y at the turning point, all we have to do is go and substitute in that equation because we've got x at the turning point. That's 2 into 1 over 4 squared plus x. Was it x or 3x? Let's just quickly check that. It's actually 3x. That was 3x there. I'll just have to correct this quickly. That's a 3 there. And that becomes 3 over 2. The whole picture has changed. And if I can run quickly there, that's 2 times a. Then the b was 3. Yes, the b was 3. And the a was b over 2. The 3 is here. And that's still the 2 there. So that's 3 over 4. Minus 3 over 4. Okay, bear with me there. Minus 3 over 4. And where we see, all right, let's see, that's a 3 there. Let's go, we need to just quickly wrap it up here. And that is supposed to be 3 into minus 3 over 4. All right, so what you'll then have is a 9 times 2, that's 18 over 4, minus 9 over 4. All right, so that gives us 9 over 4. So we then come and represent all these values here, and this has been shifted to the left, so your symmetry is over there, and let me just wrap it up. It passes through there, and the turning point is over there. That's how your graph is going to look like. All right, so we've shown the important features because this was, our other x-intercept, which was minus 3 over 2. Yes, minus 3 over 2 and 0. And that we said is minus 3 over, that's it. Okay, so I think we can wrap it up there. Minus 3 over 4. Okay, Katleho?
Okay, thank you,
Yeah,
Iti.
all right.
Thank you for that.
Great.
Thank you, Mindsetters. It was such a jam-packed show. As we know, time goes extremely fast when we're having fun. So I hope you guys had all the fun that you could have today with our functions. I hope you guys took extra notes and everything, and you're actually on the ball. Thank you again to Liberty for such an awesome show. Grade 12s are up next, so call all your grade 12 friends. If you still want to join us, please do. The more the merrier. Bye, guys.